Okay, next we are going to learn how to multiply radicals. Note that we can only multiply radicals if they have the same index. So here I have index n and I have index n. So to multiply two radicals, we just have to multiply the coefficients a and b, get the product of a and b, and then multiply our radicands x times y. And then just simplify our radical expression. So let's have our first example. Let's solve example number 2. So here I have the same index. Actually, for this particular unit, we will have the same index 2 or index 3. So for this presentation, we will have all index 2. Alright, so here I have a coefficient of 1. So I just have to multiply 1 and 5. That's 5. And then we are going to multiply 15 and 18. Next, we are going to simplify the square root of 15 times 18. So we are going to use our prime factorization method here. So I'm going to get all the prime factors of 15. So I can divide 15 by 3. The result is 5. Now for 18, I can divide 18 by 3. The result is 6. Divide 6 by 3, we'll get 2. So in this case, the prime factors of 15 are 3 and 5. 18, the prime factors are 3, 3, and 2. Now I have a pair here. Okay, this is actually 9. So when you take square root of 9, it will become equal to 3. So 3 will go outside the radical sign. Now I have 3, 5, and 2. Now these remaining prime factors, we just need to multiply these three numbers. So 3 times 5 is 15 times 2 is equal to 30. So 5 times 3 is 15, is square root of 30. Okay, let's solve example number 3. Again, multiply our coefficients. 2ac times a will get 2a squared c, and then multiply our radicands. So I have here 18 times 3, and then we have a cube and a, that's a4, and then b8 times b, that's b9, and then I have the variable c here. Now for our 18 and 3, we can just divide 18 by 3. The result is 6. Divide 6 by 3, we'll get 2. Now the other number here, 3, is already a prime number. So in this case, we can get a pair of 3 here. So that this 3 will go out. So 2 times 3, a squared c. And then the remaining factors, 2 and 3, we just have to multiply. So 2 and 3 is equal to 6. Now I have here a4. Now b9, the exponent of b is an odd number. So we have to rewrite b9 as b8 times b raised to 1. And then we just have to bring down our variable c. So 2 times 3 is 6. A squared c. Now remember that when you take the square root of a variable in which the variable has an even exponent, we just have to divide the exponent. So in this case, a4, 4 divided by 2 is 2, so we'll have a squared for a4. And then the square root of b8, we just have to divide our 8 by 2, and that's b4. Okay, so we're done with a4 and b8. Just bring down your b raised to 1 and c raised to 1. Next, let's simplify our coefficients. 6 times a squared is a4, b4, and then just bring down your c times the square root of 6bc. Alright, let's solve example number 6. Again, multiply our coefficients. 6 times negative 8, negative 48, and then multiply our radicands. I have here 2 times 8, which is 16. P squared times p squared is p raised to 4. Now 16 is a perfect square, so we can extract the square root of 16 as 4. Same thing with our p raised to 4. It is a perfect square. So the square root of p4 is p squared. Multiply negative 48 by 4. We will have negative 192 p squared. So this will be our final answer. Alright, example problem number 7. I don't have a coefficient here, so we have 1 and 1. So 1 times 1 is just equal to 1. Let's multiply our radicands. So I have here 12 and then 54. Now n cubed and n squared, it's n raised to 5. Okay, so let's simplify our 12 and 54. So 12, I can divide 12 by 2, we'll get 6. Divide 6 by 2, we'll get 3. For 54, I can divide 54 by 2, we'll get 27. Divide 27 by 3, we'll get 9. Then divide 9 by 3, we'll get 3 here. Alright, so we have here 2, 2, 3. I have 2, 3, and then 3, and then 3 here. So we have a pair of 2. So that's square root of 4, which is equal to 2. I have another, well, I have a pair of 3 here, and then another pair of 3. And then this number here stays inside. So we have here 2 times 3 equals 6, times 3, 18, times square root of 2. Now, I still have the variable n5. So for n5, we are going to write this as n4n. So remember that whenever we have an odd exponent, we just have to remove 1 from that exponent and the exponent will become even. And once we have an even exponent, we can just take the square root of n raised to an even exponent by dividing the exponent by 2. In this case, 4 divided by 2 is n squared. Now, just bring down your n. So our final answer is 18 n squared times square root of 2n. Alright, problem number 10. We don't have any coefficients, so we just have to multiply our radicand. So 48 times 6, I have n19 times n5, that's n raised to 24. Now for the 48, we can divide 48 by 2, we'll get 24. Divide 24 by 2, we'll get 12. Divide 12 by 2, we'll get 6. Divide by 2, we'll get 3. Now I have 6 here. Divide this by 2, we'll get 3. So I have 2, 2, 2, 2, 3, 2, and 3. So we can write 2 times 2 times 2 times 2, and then times 3 here, and then times 2, and then times 3. Pair of 2, or another pair of 2, pair of 3, and then the 2 stays inside. Now I have n raised to 24. Since the exponent of n is even, we can just take the we can just divide 24 by 2, so it will become n raised to 12. Just bring down 2 times 2 times 3, which is equal to 12. And then of course we have the 2 inside the radical sign. So this will be our final answer. Alright, let's have one last example. First, multiply our coefficients. 2 times negative 7, that's negative 14. Then multiply our radicands. 3 times 6 is 18. Y times y5 is y raised to 6. Now 18, we can divide 18 by 2, that's 9. Divide by 3, we'll get 3 here. So we have a pair of 3. Okay, this 3 will go out, and then 2 stays inside. multiplied with y raised to 6. Negative 14 times 3 is equal to negative 42. Since the exponent of y is an even number, we can just take half of 6, which is y cubed. So this will be our final answer.